Okay, so our last form that we're looking at is called factored form, and this is a nice form because it helps us find the x-intercepts really quickly. So this is how you do it. So finding the vertex, so if this is your equation over here, f of x equals a times x minus x1, and then x minus x2. The vertex is going to be the average of the x-coordinates. So you're going to take x1 plus x2 over 2. So that's going to equal the x-coordinate, and much like standard form, you're going to find the x-coordinate first and then substitute back in to find the y-coordinate. So let's go ahead and take a look at an example down here. We've got x minus 3 times x plus 5. So the vertex, you're going to take 3 plus negative 5 over 2, and this is going to be negative 1. So again, the reason why we're taking negative 5 is, if you notice, it is a positive sign, and in our equation it's subtracting. So in order for that second one to be a positive sign here, that value of x squared needs to be negative to change it. So that's why I took the negative 5. So that's your x-coordinate over here, and now I'm going to substitute that back in. So negative 1 minus 3 and negative 1 plus 5. So this is going to be negative 4 times 4, which is negative 16. So that's going to be the vertex point there. So your line of symmetry is going to be x equals negative 1. Your y-intercept is where x is 0. So it's negative 15. So 0, negative 15 is one coordinate. And our x-intercepts are where y equals 0. So using our zero product property, we're going to set each factor equal to 0. And solve. So x is going to equal 3 and x is going to equal negative 5. So your y-intercepts are going to be 3, 0, and negative 5, 0. Whoops. 0. Okay, so those are our two x-intercepts. So now let's go ahead and graph all these critical points here. Negative 116, I'm going to use I'm going to go down by 2's here on the y-axis. So negative 1, and this is going to be 2, 4, 6, 8, 10, 10, 12, 14, 16. So right there. So again, I just went down by 2's on the y-axis. So that's all your vertex, and now your x-intercepts are 3, negative 5. So 3, 1, 2, 3, and negative 5, 1, 2, 3, 4, 5. So a good indication that your vertex you found correctly is it's in between the x-coordinates. It's exactly in between. So if I draw my line of symmetry at x equals negative 1, it's going to be the same units away from the x-intercept. So 1, 2, 3, 4, and 1, 2, 3, 4. So since it's exactly the same on both sides, I know that I have found it correctly. Okay. And then last but not least, I think I've got a y-intercept out here. It's at 0, negative 15. So that's going to be right in between. It's going to be right there. So our last thing to look at is this limit here, and again it's nice because the lower one is at negative 5, and since I have a y-coordinate, I know where this graph is at negative 5 because it's an x-intercept. I don't have to determine anything. What I do have to make sure is that it's a closed circle on negative 5 because of that bracket. So I'm going to really make sure that is known. And then the upper one is where x goes to infinity, so I know this is just going to keep on going. So I'm going to trace here from negative 5, go down to my vertex, pick up my y-intercept, and continue on into positive infinity. So my range, again, from low to high is going to be from negative 16. Remember, we went down by 2's, and that's going to be a bracket because it is included, and then all the way up to positive infinity because of this arrow there with a parentheses. So that is your last form that we are graphing in. So go ahead and finish up the practice 2's.